Hello class, welcome to week 9 of INST 414. As usual, we'll start the week and lecture with some announcements. The main one being that my son was born 2 weeks ago as of Tuesday, so that means I am trying to adjust to a new life as a parent, and I appreciate any patience you can provide as we move through this transition. So hopefully it shouldn't be a big impact for you, but I do apologize if anything takes longer than normal to get back to you. Secondly, just to give you an update on the Medium articles that you all have been publishing. So a number of them have been up and getting views and reads, so that's a good stat to see that a number of your articles are getting some traction online. So as I mentioned at the beginning of the semester, part of the reason I do this is to give you some exposure and give you some content that you can add to your portfolio and get some feedback potentially from the wider internet audience. Module 2, so last week we've talked, or I guess before the spring break, most of the Module 1 assignments have been graded. I have a walkthrough for the Module 1 demonstrations. Now we have the Module 2 walkthrough available as well. So if you go to the GitHub repository for the course, there's the graph analytics notebook, that one at the end, where we create a graph using the IMDb dataset. I've published that walkthrough, so this was done by our TA, Tanishq. That's up on YouTube now. The link is here. It's also in Elm, so you can check it out on the course webpage. For assignment 3, remember this assignment is about identifying similar items or measuring similarity between items. I am working on getting the walkthrough for this code up and posted. Hopefully this will be this week as well, so this code is relatively straightforward. The main thing is we look at movies in our data set and then use Jacquard similarity to evaluate overlap between sets of actors in movies. And we select, in this example, a particular movie, the Query movie, just looking at Star Wars Episode 2. And then we evaluate distances between Star Wars Episode 2 and all the other movies in our data set and print them out. So I'll have an example walkthrough for that I might expand a little bit with some other data as well, but you can look forward to that soon. For the assignment 4 on clustering, so this is due at the end of this week. We've gone through what this means. The main things to do for this, look for data that's relevant to you. You can use the IMDb data if you like, or any other data that you can pull from Kaggle or PushShift or other spaces that we've talked about in the past. You want to read this data into Python. You can, depending on how you collected it, you can use read on files or readline, or you can just use pandas read JSON or read CSV. It's relatively straightforward for that. But then you want to have your data and convert it into some matrix form of rows and columns, where rows represent the samples and columns represent the features. So the samples are the things that you want to cluster, and the features are the things you'll use to evaluate similarity or evaluate similarity across the elements in your data set. If you need to, you can consider using dimensionality reduction, so truncated SVD or PCA, depending on how big your data is. In the example I have in GitHub for k-means, you'll see that the method for selecting k is a little bit clearer if you use dimensionality reduction first, but that's certainly not necessary, though it does help for some scalability issues. Then you want to select some reasonable value for k. How you do that is kind of up to you, but you do need to justify it. If you are using some domain knowledge from your experience with the data, that's fine. You just need to explain, well, there are 2 parties in this country, so we're dividing people into 2 clusters, or there are 8 genres we care about, so we're going to divide this content into k equals 8. Or you are going to use some optimization, either like evaluating silhouette metrics across a number of different values for k, or using the elbow method and inertia. Whatever you want to do, you're welcome to explore different options for selecting values of k, but you do need to justify what value of k you landed on. And then apply your clustering algorithm to this data. You can use sklearn for this. The ordering of operations here is a little bit nebulous, because if you're using domain knowledge and sort of establishing k by fiat, then you would select your k before you apply your clustering algorithm. But if you're going to use the elbow method, you're going to sort of go back and forth between applying the clustering the clustering algorithm and evaluating the quality using inertia or something along those lines. And then lastly, I want you to pull some samples from each cluster that you identify and describe why are they similar or how are they similar. So that way you get some sense of describing what each cluster in your data set means. Now the main ways to get points for this, the main sources of points for this assignment are this point selecting a reasonable value for k and your justification for that. So it is crucial that you specify why you selected some k value. And then the inspection and description of the clusters in the data that you've identified, that's also a key element. So clustering is valuable, and it actually provides some value for downstream tasks. But for here, what I want you to do is explain or sort of describe what you think the clusters mean, and it's important that you have some samples for how to do that. I'm working on getting the code for this. Primary, it'll be the k-means code, the 02-k-means notebook, because that one's a little bit more complete and I think a little bit faster than the agglomerative clustering or hierarchical clustering code there. But I'll have an example for that as soon as possible. That's it for the assignments. The next thing to discuss is the semester project. Do remember that there is an assignment, or part of the semester project assignment includes engagement with me and the TA. So I have this set up for bi-weekly project meetings, drop into office hours. It doesn't have to be for very long. It doesn't have to be the same person every time, but at least once every 2 weeks, I expect to see somebody from your project group come into office hours to describe progress that you've made or any sort of issues that you've encountered. So it's important that you be doing this. Secondly, the data collection report. We'll have you feedback for this by the end of the week. I should post it actually today. And then the intermediate report is due next week, so that's April 6th. The main things you need to describe here are what progress you've made towards your proposed goals. So that your goals, you should state what your goals are, what the core objectives of your project are, and then what sort of analysis have you done thus far. Some things that you could describe include, what have other people done to try and solve this problem? What are some of the basic approaches that you might have tried, and were they sufficient or not? And then what sort of analytics have you gotten out of your data so far? Really the main thing here is you should describe why you're doing this project, what its goals are, and what analyses that you've done to this date. It doesn't have to be complete by any means, but just doing data collection is insufficient for this. You need to have made some progress on analysis. So whether that's data pre-processing to get you to the point where you can do better analysis or more in-depth analysis, that's a thing that you should discuss. You can spend some time talking about how other people have tried to solve this problem that gave you insight. That'll help you sort of justify why this project is valuable or important. And then any preliminary analysis that you've done is going to be useful. It's not meant to be very long, so this is really only supposed to be like a couple of pages per student in your group to give you opportunity to describe the work you've done to date and justify why you think this work is important. Because you can reuse this content for your final report, but the way the evaluation is done for the final is going to be slightly different for this. Because the way evaluation works for the intermediate report is I will collect all of the reports from all of the projects, all the project teams, and then share them amongst the class in a blinded way. So that means nobody will know which group is which when they're doing evaluation. And I will ask your fellow students what they think about the project. I'll talk about that in a minute. But crucially, because this evaluation is meant to be blind and it's going to be reviewed by your peers, it is important that your PDF that you upload with your project report does not include your name. Do not include your name, do not include your group ID, anything like that. I will handle that. But please make sure that you do not include identifying information in your material, since I will be sharing it with the rest of the class, and we don't want to reveal names or group affiliations until after that evaluation is done. So please do not include your name on the PDF. All right, so what is the review going to look like? Really, what your fellow students are going to be looking at, or the questions I will ask them to answer, are to identify what the main contribution of this project is, why is it important, what sort of related work that was discussed gives you some context for this project, what are its key strengths and weaknesses, so what are the strengths of the analysis that you've done, or the strengths of the motivations, what are the weaknesses that have come up, and what insights do you think are being extracted from the data? How is that insight actionable? And then a letter grade, essentially. So the letter grade is going to be partially, or one of the major drivers for evaluation for the report. So really, you should be convincing your fellow students about what is important, or what you're doing, how what you're doing is important, and how much progress you've made, and what is the strength of that progress. My feeling is this peer review gives you the opportunity to see what other students may think about the work you're doing, and their feedback has often been useful to help you refine the next steps, or what you might need to do for evaluation or analysis. And ultimately, at the end of the class, you'll have a presentation and a final report, and the final presentation will be also evaluated by peers. So take the feedback that your peers give you for the report, for the intermediate report, try and address them, because that will likely come back with the final presentation. That's it for assignments between the module assignments and the semester project. This week starts Module 5 on probability. So we have a few learning objectives here. The first one, I sort of refresh if you've already explored probability before. I think you should have as part of the stats course in the prereqs. But this is going to be a relatively lightweight set of lectures for Module 5. It's mostly to get you bridged, or to bridge the gap between probability and stats that you may have seen, and how we'll use that for supervised learning in the Module 6, and get some language and terminology under our belt so we can talk about this. So the first learning objective here in this week is going to be able to define a discrete random variable, what its sample space is, and at least be able to talk about what it means to say the probability distribution of outcomes in the sample space. We'll look at discrete things for now, primarily as a way to make things simple. Then you should be able to identify whether two events are independent. What does it mean for two events to be probabilistically independent? You should be able to calculate conditional probability. So what is the probability of an event given that another event happens? We'll talk about that more next week with Bayes. And you should be able to talk about the probability of a sample being in a particular cluster. So here's the bridge between probability and what we've been doing so far with machine learning, and you'll see some of the work here come back when we come to Module 6. So for these first three learning objectives, I have posted 2 videos from the Crash Course Statistics course. They have 2 probability videos that I think are quite informative, and their production value is way better than anything I could do. So those 2 videos will give you, I think, the majority of background you need for probability, and then I'll have an additional lecture video for the connection between the probability work and the clustering that we've been doing in the previous module. So you can see how we can apply some of the work from probability to what we've been doing with clustering and unsupervised learning, which will help us next week and in the coming module when we actually use these probabilistic methods to do classification. For next week, we're going to focus on more sophisticated or more complex probability questions, so looking at joint probabilities and pushing on conditional probabilities. So part of the joint probability piece is to be able to calculate marginal probabilities. So given pairs of events, can you marginalize out the one event to get the probability of the second event happening? We'll talk about Bayes' theorem, and then we'll use Bayes' theorem to identify most likely clusters, which will set us up for doing naive Bayes classification, or Bayes classifying, or doing Bayes classification in Module 6 when we talk about supervised learning. For next week, the main things are your semester projects, the intermediate review or intermediate report is due. That's crucial that you get that on time, because I will be sharing this content with your fellow students. So please get this in as soon as we're on the due date, because I have less opportunity or less latitude to delay that. And then I don't have any new readings for next week, so next week we'll end or bookend the probability section, and then I'll provide you readings next week for Module 6 and supervised learning for the week after that. But there are no readings for this coming week. If you have any questions, by all means reach out to me, come by office hours, or post any questions you might have in the discussion forum.